work is very exciting because I mean, you work at CERN, you have always some new challenges, also with the teams, because they are very, I mean, usually you learn every day with different topics and stuff. What I do currently is I'm working on the cooling system for CMS and Atlas, as it's currently with CERN for the high luminosity phase. And I mean, despite cooling and refrigeration being a well-known topic, and you do this industry-wise, when you go a bit for the detector part, particle protection part, you have all these new challenges, and we are learning every day. That's cool.
Hi everyone, I'm Giulia Terragni. I work at CERN. I'm a PhD working on medical applications, in particular improving the performance of time of flight for different emission tomography. And I'm currently working on improving my setup and in particular automatizing it to be able to perform all the measurements we need. So everything we can do, since we cannot control every step and every channel of all the detectors, we need to automatize everything and use robotics. So it's in the blood of everything that we're doing at CERN.
Who are you and what you're doing in CERN?
Hi, my name is Malene Turner. I'm an accelerator physicist at CERN, and my job is to develop the next generation of particle accelerators. I think robotics and engineering is very important because, you know, physicists have a lot of ideas, but then you need to realize those ideas. Like, you need to go from a concept and something that's in your head to something that you actually put there. And it takes a lot of engineering. For example, our plasma is basically engineering. The concept in our head is, let's make a plasma, but then let's build the plasma. That's engineering, right? The idea in your head, that may be physics. What you're doing with it may be physics, but actually putting it there, that's all engineering. And the same goes with robotics. So for example, sometimes we cannot get to points, or things need to be very reproducible, need to be done exactly the same way every single time, and humans are not very good at it. And I think robots are very good at it. So basically, making things happen for physicists is all engineering and robotics. So.
Okay, thank you so much.
You're welcome.
Okay, so hi, my name is Moritz. I'm a physicist working at CERN, and personally I work on irradiated silicon detectors. So the question was, why do we use robotics, or why is it important? So from my work, I know that radiation levels in the experiments are very high, so we need investigating how to use robots to perform tasks for us where humans are not able to access because of the high radiation levels. Also, for example, for if we want to move radioactive stuff, so it can be very helpful to have robots do that where humans cannot because of security and safety reasons.
Thank you so much.
Yeah,
Hi, I'm Anya. I'm a science communicator at CERN, and I'm really excited to see how robotics is already entering high schools. I think it's super important that kids and also later on adults get to know what robots can do, not only the way we see it on TV, but also in various other fields, I don't know, in high radiation areas and data, and well, everywhere. You wouldn't even think of where you can find them. And I think FIRST Robotics is really such a fantastic place to learn that, and also to exchange some experiences with kids from all around the world. Thank you.
My name is Pierre. I'm working with the University of Oxford, and I'm working on a project based at CERN. The goal there is to be able to use very high energy electrons at ultra high dose rate to cure cancer. To be able to do all these irradiations, we designed and built a robotic system to be able to put in the beam different types of samples. So the robot is fairly simple, but it's being able to grab up to 32 samples in one run, put these samples in the beam, in air or in water, with a 50 micrometer accuracy. We use this robot to avoid having to enter the tunnel between two irradiations and to be able to have the exact dose required for cancer treatment. So we've done different types of irradiations on biological samples such as zebrafish eggs or fruit fly larvae to check that we can use very high energy electrons again to destroy cancerous cells. But we also use this robotic system to develop new ways to measure the dose in a real-time way.
I'm German, I work at CERN and I am in charge of Science Gateway Education Labs. Many opportunities for students at CERN, some of them already for high school students. We have a competition called Beamline for Schools where you can apply with experiments to do it with Beamline. We have the CERN Survey Education Program that has a series of online material and then an on-site camp, and there are also different internship programs already at high school level. The moment you're at university, there are many more opportunities. For example, you can come to CERN as a technical student or administrative student after 18 months of studies and then have 1 year paid internship, nicely paid internship in Switzerland. And then we have a summer student program that will pass 3 years of your studies for many different jobs at CERN. So what many people don't know is that CERN doesn't really employ many physicists. The highest proportion of people we employ are engineers because CERN provides accelerators. So we need lots of people to build new machines, to maintain the machines, and to develop new technologies for our future missions to solve the problems we have currently. So for example, if we think about building a 100-kilometer ring, we cannot have humans do all the maintenance. So there's actually lots of research going on what kind of robots can help us to help us maintain these huge accelerators. So lots of opportunities for engineers in all kinds of fields. So yeah, if you're an engineering student, make sure to go to careers at CERN and check out our opportunities.
Thank you so much.
I'm the digital education content creator at Science Gateway, the new outreach center for CERN. And your question was, what is it to work at CERN on a day? What is it like to work at CERN on a day-to-day basis? It's pretty fun because the organization is so huge that there is always something new to learn. You can get to know about the theory, about the experiments, about material science, about in computing. I really like having an overview of all the different jobs. So for me, it's a journey of discovery working at CERN. It's also amazing because it's very there are so many cultures that you always get to interact with people who have a different mindset. So when you go to the restaurant, you get to hear many languages, and sometimes I can't even tell what the language is. So I don't know, Turkish or Finnish or amazing things like that. So it's really valuable, this intercultural experience. I am a physicist originally, but I'm from a very different field from what people do at CERN. I'm a fluid dynamicist and I worked at the interface between chemistry and physics, so very far away from particle physics. But as a grad student, I had a side project, and that side project was a YouTube channel. So I was teaming up with artists and film students and scientists to make videos that showcase the beauty of fluid dynamics. And that's what actually got me into CERN, because the skill that I developed on the side, the ability to be a film person on top of being a physicist, is great for my job now, because I get to make videos about the whole of physics of what is done at CERN. And so if you can craft yourself sort of a unique personality or a unique skills set of skills, then you'll be very valuable to a place like CERN. So I think that's a good pathway to enter.